Welcome to Learning with Philemon. In this video, we will be looking at molecules in which there are 5 electron domains around the central atom. For an introduction to valence shell electron pair repulsion theory, VSEPR, please see the previous video, VSEPR. Phosphorus pentachloride PCl5 has the following structure. Phosphorus has 5 valence electrons. It uses all of these to form 5 single bonds with chlorine atoms. Note that chlorine atoms have 7 valence electrons and require only one single bond to complete their octet. As phosphorus uses its 5 valence electrons, it has no lone pairs of electrons. There are 5 electron domains around phosphorus. All of them are bonding pairs. Note that phosphorus has 10 valence electrons after bonding. This is called an expanded octet, when an atom has more than 8 valence electrons after bonding. Elements in period 3 and above are able to have expanded octets as the electrons can occupy their d orbitals. The molecular geometry is trigonal bipyramidal. These 3 chlorine atoms are in the same plane, and the bond angles are 120 degrees, just like in the trigonal planar geometry. There are 2 more chlorine atoms on the vertical axis that are perpendicular 90 degrees to this plane. The bond angle between the 2 chlorine atoms on the axis is 180 degrees. On chemtube3d.com, see the link in the description, you can visualize this 3-dimensional structure. Rotating the molecule so that the chlorine atom on the vertical axis is in the center, we can see the 3 chlorine atoms in the same plane. The bond angles are 120 degrees. Rotating the molecule so that the 2 chlorine atoms on the axis are vertical, we clearly see the 90-degree angle. There are more features you can explore, such as symmetry elements and spinning on this website. Sulfur tetrafluoride, SF4, has the following structure. Sulfur has 6 valence electrons. It uses 4 of these to form 4 single bonds with fluorine atoms, leaving 1 lone pair of electrons that remains on sulfur. To draw correct Lewis diagrams, remember to always count the valence electrons in the central atom so that you do not forget any remaining lone pairs. Note that fluorine atoms, like chlorine atoms, have 7 valence electrons and require only 1 single bond to complete their octet. There are 5 electron domains around sulfur. As there are 4 bonding pairs and 1 lone pair, the molecular geometry is a seesaw. This is similar to the trigonal bipyramidal geometry, but the bond angles are a bit lower. This is because the lone pair of electrons repels the bonding pairs, making them move closer together. Chlorine trifluoride, ClF3, has the following structure. Chlorine has 7 valence electrons. It uses 3 of these to form 3 single bonds with 3 fluorine atoms, leaving 2 lone pairs of electrons. Note that chlorine now has 10 valence electrons after bonding, an expanded octet. There are 5 electron domains around chlorine. As there are 3 bonding pairs and 2 lone pairs, the molecular geometry is called T-shape. This is similar to the trigonal bipyramidal geometry, but there is only 1 bond angle to consider. The bond angle between chlorine-fluorine bonds is less than 90 degrees due to the repulsion from the lone pairs of electrons. Xenon difluoride, XeF2, has the following structure. Xenon, like the other noble gases, has a complete outer shell, so it is unreactive. However, it can form some compounds. Xenon has 8 valence electrons. It uses 2 of these to form 2 single bonds with 2 fluorine atoms, leaving 3 lone pairs of electrons. Note that xenon now has 10 valence electrons after bonding, an expanded octet. There are 5 electron domains around xenon. As there are 2 bonding pairs and 3 lone pairs, the molecular geometry is linear. This is because the bond angle is 180 degrees, just like in a linear geometry with only 2 electron domains. The 3 lone pairs of electrons are in a plane perpendicular to the xenon-fluorine bonds. Here we can see that there are 2 structures that have a linear geometry, one with 2 electron domains and one with 5. Make sure to differentiate between the 2. Remember that all molecules with 5 electron domains around the central atom, seen in this row, have the same electron geometry. They all have a trigonal bipyramidal electron geometry. However, depending on the number of bonding and lone pairs of electrons, the molecular geometries differ from trigonal bipyramidal, seesaw, T-shape, or linear. As discussed, all 4 shapes have a very similar 3-dimensional structure. To consolidate your learning, I would suggest you attempt to draw different compounds, build them using Molymods, or view them using the chemtube3d.com website. Thank you for listening. If you haven't already, please subscribe for more content. Stay curious.